Okay, so now I'm going to look at, I'm going to get into the calculations of this thing that we're interested in, this price elasticity of demand. So what I have set up here is a segment of a demand schedule and the corresponding drawing of that along a demand curve, that segment. Um, what I'm talking about is, and I'm going to reveal this in just a second, what I'm talking about is two prices. When the price is $5, the quantity demanded is 4 units for whatever this good is. Call it, that, whatever. Now, when the price falls to $4, what should happen to the quantity demanded? Let's do this as a little review. So when the price was 5, the quantity demanded was 4 units. When the price falls to, let's say, $4 per unit, what should happen to that number of units that is demanded? It should rise, right? So what I've set up here is perhaps overly simple. Here's what I said out loud. When the price was 5, the quantity demanded was 4. Then the price fell and the quantity demanded indeed rose, let's say to 5 units. So over here is a drawing of that, just a segment of the demand curve for this good, whatever this good is. When the price was 5, the quantity demanded was 4 units. When the price falls to 4, the quantity demanded rises to 5 units. So I am using the exact same numbers, just in reverse order. That is meant to be simple. It might be too simple. Hopefully it doesn't overcomplicate things. But let's see if we can use these really simple numbers for our first go around at calculating this price elasticity of demand, right? That's the objective here. So let's start off with, let's have a price increase, because that's easiest to feel, I think. So we're going to have the price rise from $4 to $5. So the price is going to rise. So what's going to happen necessarily is that the quantity demanded will fall, right? So we're talking about this occurrence all in orange. That's all the same way to say the same thing. Price is rising, so the quantity demanded is going to go to this 4. It's going up in my number scale, my schedule here, because it's moving along with it. And there it is over here. When the price rises, the quantity demanded falls to 4. So this point is this point, and this point is this point. These are just ordered pairs. We're moving this way in the ordered pairs, and that's the outcome over here. So let's now calculate our price elasticity of demand. So here's something that students have found handy outside of this class and in this class. Percent change. As I said, I know it's true. People get very nervous about math. And percent change is something that sometimes it's something that people aren't nervous about until they realize that it's not as easy as they thought and they become very nervous. I can tell you exactly how I came to realize this. I was at an algebra test at Cecil Community College, and I thought part of the material that I knew was going to be on the test was percent change. And I thought, well, I know percent change is easy, right? I go to a store, if something's 10% off, I move over the tens place and I subtract that from the price, and that's easy. Or if something rises 10%, I just can quickly figure out 10% is just move the decimal over and you add that to it. So if something costs $1 and it rises by 10%, well, it becomes $1.10. What's hard about that? I can do that. That's easy. So I walked in without really focusing on how to do that. I just thought I took that one for granted. And then I got there, and it turned out the numbers weren't like $1 to $1.10. No, they were more like $156 to $172. And then I had to say to myself, oh dear, I didn't study that component because I took it for granted. So I was tenacious. I wouldn't let go of any points. I went back to it at the end of the test, and I said to myself, if I know that if something goes from $1 to $1.10 is a 10% increase in price, what am I doing there? What are the mechanics of what's going on in my head that I think is easy, and can I apply that to harder numbers? And I came up with this. Percent change is always equal to, it's like a little rhythm, okay? New minus old over old. New minus old over old will get you percent change every time. So in my $1.10 example, 110 minus 1.10, $1.10, minus 1.0, a dollar, over 1.0, because it rose from $1 to $1.10. So it's 1.10 minus 1.00 over 1.00. You have a dime up here over 1. Anything divided by 1 is itself. That's 0.10. 0.10 is another expression of 10%. You move the decimal over 2 places for percent change. Okay, I have a bad habit of, if I see 0.53, I immediately call that 53%, because it always is. You just are moving the decimal over 2 places. I hope that's clear. I know the textbook explanation of converting from a decimal to percent is far more wordy than that. I try to avoid wordy. So if something is 0.12, that's synonymous with 12%. If something is 1.12, that's 112%. You're just moving the decimal over. So if the numbers were like, what's the percent change if a value goes from 153 to 176? That's 176 minus 153 over 153. That's new minus old over old. It went from 153 to 176. So the new value is the 176. 153 was the old value. You take that difference and subtract and divide it by the base value of 153, or the old value of 153, and you're going to get a decimal there. And I'm going to guess that that decimal would come out to be about somewhere around 0.1, which is about 10%. I made up those numbers. I didn't do that calculation, but that's how you would do that with those numbers. Don't worry, we're going to have plenty of examples starting right now. So I'm looking for percent change in the quantity demanded over the percent change in price. So let me set each of these up with a complex fraction, which I know is going to make some people nervous, but it's just laying, a complex fraction is just laying out the steps we have to do all in one piece. It looks intimidating, but it really isn't. So here is this line right there. Okay? Now percent change in quantity demanded is going to be the new minus old over old in the quantity demanded. So I'm just going to lay that all out at one time. So the new quantity demanded is 4 minus the old is 5 over the old is 5. So percent change in quantity demanded. New, because we came to that from the old. So the new is right there, minus the old is right there, over the old is right there. Over the percent change in price. So my new price is 5. Thus my old price was 4 over 4. So new, the price went up, so that's the new one. Old, it went from there to there, so that's the old one. Over the old one, that goes there. So I've laid out a complex fraction, which I know looks intimidating, but it's actually just laying out everything we have to do, and then we use our order of operations to handle this. So I'm going to simplify the top and the bottom so that this becomes 4 minus 5 is negative 1 over 5, and 5 minus 4 is 1 over 4. So I'm just taking this one step at a time, and that's what I have. Okay? Now, handling complex fractions really freaks people out, but it's not too bad. All you do is flip and multiply. So I'm going to flip this, flippity flip, and multiply it against that. So this is equal to negative 1/5. I just copied this down here, times, I'm flipping 4 over 1. That's how you handle a complex fraction. And multiplying fractions, there's pretty much nothing easier in the world. You just multiply straight across. And so that is negative 4. There's nothing easier in the world, and I go and make a mistake. Negative 4, that's negative 1 times 4, over 5 times 1, 5. And so this is negative 4/5, which is negative 0.8. I'll go ahead and convert it to a decimal in my last step here. So that's negative 0.8. When I gave you the E is less than 1, E is greater than 1 thing, I didn't mention anything about negative numbers. You know why? Because these will always come out to be negative because the slope of our demand curve is negative. So we don't care about that. We ignore the sign. Or if you want to be mathematically correct, you could say it's the absolute value of our calculation. We're only going to look at it in positive terms. We're just going to ignore that sign. So therefore, E is equal to 0.8. So using our language that I had on the whiteboard in the last segment, we would say that this elasticity, price elasticity of demand for this good is inelastic. These consumers appear to be not very responsive to price changes. That would be the whole point to doing this. But wait, because if I haven't changed that purple line that is the demand curve, what if instead of a price rise, we had had a price fall? If the consumers are the same, because the demand curve is the same, shouldn't the elasticity be the same on the way down as it was on the way up? Well, of course it should be, but let's do a little calculation there. If nothing else, it gives us practice using our percent change and the general formula that we have. So now I'm going to talk about a price fall. And I'm going to erase everything orange that I did with the price rise, and I switched to green. And we're going to start all over. We're going to do that calculation again. And I just want you to remember, I'm going to leave it on there that therefore E is equal to 0.8. I'm going to leave that little piece on there and erase everything else. And let's see what we get with a price fall using our conceptual model here of elasticity. Okay, percent change is new minus old over old. I'm dealing with quantity on the top. So my elasticity then is equal to my quantity. My new quantity is 5, right? Because we're talking about a price rise. So new minus old over old. I'm sorry, this bar is my main bar. So it's new minus old over old. 5 minus 4 over 4. This will represent my percent change in the quantity demanded. New, because the price fell, the quantity is here now, minus old over old. That's the percent change in the quantity demanded, because that's what percent change is, and those are the values just plugged in right there for percent change quantity demanded. Given this price fall, so my new price is 4 minus 5, because that was the old price, over 5. 4 minus 5 over 5. So I've laid everything out. This is now here with these values, and I've used the fact that percent change is new minus old over old to do it. So now I just have to grind it out. 5 minus 4 is equal to 1, and the 4 is just right there. 4 minus 5 is equal to negative 1. We know at the end we're not going to care about that, but this is the first step to simplifying that. Now I have 1/4 over negative 1/5. Let's just carry it over. So now I'll do it up here actually. I'm going to do the flip and multiply, whoop, and this becomes the 1/4, that's just falling right there, times, I'm flipping these, so this is 5 over negative 1. Let me get my arrow out of there. And this is multiplying, it's just straight across, so this is 5 over negative 4. Oh dear, here comes the problem. 5 over negative 4 is negative 1.25. That's the elasticity I get when I calculate the price fall. But I did not redraw my line, so this line is the same. How could I have a different elasticity? Well, therefore, E is equal to 1.25 because I ignored the sign. So now comparing what I calculated in orange for the price rise to what I just calculated in green for the price fall, I get a different elasticity. Well, the purple line was not moved. The points weren't moved. All I changed was the arrows and the color of the arrows. So how could it be that consumers are inelastic one way, but elastic the other way along the same demand curve. That doesn't make sense. And economists then, realizing that that doesn't make sense and that that's how these numbers would play out using our simple conceptual model of the price elasticity demand, they figured out a little, I don't know, loophole or different way to handle this so that it would make sense. You should be able to get the same consumer behavior up or down the supply curve because it's the same consumers. So what we can do to remedy this problem is called the midpoint method. The midpoint method, different textbooks have slightly different names for it, but it's all the midpoint method is what it is. It's where instead of treating percent change like it is, we're going to treat it as something slightly different. With the midpoint method, instead of doing new minus old over old for our percent changes, we're going to do new minus old over the average or the middle of new and old. Let's make this clear. If you average two numbers, we all know average, right? You add them up and divide by the number there are. That's how you calculate the average in statistics, right? So, if you had 3 or 4 numbers together, let's say 4, the average of the 4 numbers is the sum of those 4 numbers, what they all add up to, divided by 4. What happens if you average 2 numbers? Pick any 2 numbers you want to. Right now I'm picking 8 and 10 in my mind. How would I average 8 and 10? 8 plus 10 is 18. How many numbers did I look at? 2. What's 18 divided by 2? 9. Well, I chose 8 and 10. What's right smack in the middle of 8 and 10? 9. You think that's a coincidence? Well, let's try some other numbers. Let's try 10 and 20. Let's spread them out a little bit. 10 and 20. What are the average of 10 and 20? You add 10 to 20, you get 30. There were 2 numbers there, so to average 2 numbers, you divide by 2. What is 30 divided by 2? That's 15. Well, what's the relationship between 15 and 10 and 20? 15 is right smack in the middle of 10 and 20. So anytime you average 2 numbers, you're finding the middle of those 2 numbers. It only works when they're 2 numbers. When you're doing averages of other numbers, there's no relationship like that I can think of, but it works every time with 2 numbers. So when we're doing the midpoint method, which is probably the hardest part of this chapter, which is probably the hardest chapter in a microeconomics principles course, when you're doing the midpoint method, here's the quote-unquote formula you need to memorize. It's not really even a formula if you think about it this way. Instead of percent change that we're going to use being new minus old over old, which percent change always is, okay? If you're dealing with prices and you're asked in your algebra class, what's the percent change for this? Remember new minus old over old. It'll work every time. But for the midpoint method, dealing with the price elasticity of demand, what you want to remember is that instead of using new minus old over old, you use new minus old over the average of new and old. New minus old over the average of new and old. So let's try that with our orange marker again, where we had a price rise. So I'm going to redraw my orange arrows all through here. We're talking about this price rise again. There are my orange arrows. Okay. So now when I set up my expression, elasticity is going to equal, I'm going to have the percent change in quantity up top, except instead of using outright percent change, midpoint method is equal to new minus old over new minus old over 2, which is the average of new and old, right? That's the midpoint method. New minus old. This is the heart of it. New minus old over new minus old over 2 is how we do the midpoint method. So let's try that here. So it's still going to be our general idea up here. It's percent change in quantity up top. So up top here, my new quantity is 4. My old was 5. Right? Because this is the movement we're going to. This is the new one, this is the old one. Now instead of being old on the bottom, it's the middle of 4 and 5. So let's just do, for now, 4 plus 5 over 2. Isn't that the average of 4 and 5? 4 plus 5 over 2? That's the average of them. It's also how we get to the middle of them. So you might have just said, I see the middle of 4 and 5. That's fine too. But in case you don't, in case it's hard numbers to see the middle of them, this will get you there. Okay? So now the price side of it. New price is 5 minus old is 4 over the average of them. Well, that's 5 plus 4 over 2. So now let's go ahead and grind all this out. 4 minus 5, that's easy. That's negative 1. 4 plus 5 is 9. Divided by 2 is 4.5. Or the middle of 4 and 5 is 4.5. Doesn't matter, however, like I said, you could see it, or maybe you don't see it, or maybe you do see it and you just want to check and make sure you see it right. That's how you get good grades. Over, that's just this bar moved over here. 5 minus 4 is 1. 4 plus 5 is still 9. Divided by 2 is 9 divided by 2 is 4.5. Okay, so now I have a complex fraction, but it isn't that complex. All it means is I flip and multiply. And this is equal to negative 1 over 4.5 times 4.5 over 1. This is negative 4.5 over 4.5. And that is equal to negative 1. And we don't care about the sign. Therefore, elasticity is equal to 1. And we said, using that key that was in the previous video, elasticity equal to 1 is called unit elastic. So this thing was unit elastic with a price rise. Well, let's make sure we get unit elastic with a price fall, because I didn't redraw this purple line. I never have. So let's go ahead and make sure it works the same with a price fall as it did with a price rise. So just like I did before, I'm going to switch to a green marker to examine the price fall to make sure this thing works the same both ways. So again, we're talking about a price fall. So everything that we're talking about, I have drawn a green arrow beside. Okay, so now elasticity, the percent change in quantity is going to go on the top. So this is the column I'm working with here, except instead of just using the real formula for quantity or for percent change, I'm going to use the midpoint method approach for percent change. And so my new quantity is 5 minus my old is 4. Over the middle of those two, we know is 4.5, but humor me. Humor me. Let's write it out. 5 plus 4 over 2 over my new price is 4. My old was 5 over the middle of 4 and 5. I know. We all know what it is, but that's 4 plus 5 over 2. Now then, let's go ahead and simplify this one step. That's negative 1 over 4. That's 9 divided by 2 is 4.5. This is positive 1. This just carried over. That's this bar. This is positive 1 over 4 and a 5 is 9 divided by 2 is 4.5. Flip and multiply. And you have to make that sound every time. Negative 1 over 4.5 times 4.5 over 1. You multiply straight across. There's nothing easier than that. Negative 4.5 over 4.5 is equal to negative 1, and we ignore the sign. Therefore, E is equal to 1. Check. We get unit elastic whether we go up or down. And it's not always going to come out to be unit elastic. That's not the point. It's unit elastic because I wanted to pick easy numbers, just 4 and 5. The point is that we will get the same value whether the price is rising or falling when and only when, I think that's true to say, when we use the midpoint method, we can get the same value whether we're rising along the demand curve or falling along the demand curve. It comes out to be the same by using this little piece right here for both our percent change in quantity and our percent change in price. So that's the midpoint method, and that's why we do it. And for your homework calculations, that's what you will do. We had to explain the other thing because it gets the main thing to walk away from is not how to calculate price elasticity of demand. after this class, most people will never do this again in their lives. But the idea of the percent change in quantity given some percent change in price is something that you will carry with you and find useful for the rest of your life. So you need that concept. That's why that's first. And then in order to survive the class and to calculate it and really get it, that's what classes are about, right? You need to have the actual midpoint method to make it happen. So that's why we're doing both. And that's about all I have to say about that.